Okay, hi guys. We're on day 5 now, block 1. We're looking at Pythagorean theorem problems. I believe you should be familiar with the Pythagorean theorem, so we'll go over it a little bit here and then do a couple of word problems, but it should be short and then you have some practice to do after. So just quick review of what the Pythagorean theorem is. It's a relationship between the sides of a right triangle. So this only works with a right triangle. We have the side across from the right angle is our hypotenuse. And then the other two sides, we usually call them legs. It doesn't matter like which is which for the formula, but yeah, the other two sides are called legs. So the relationship between the legs and the hypotenuse would be a squared plus b squared equals c squared. The order of a and b does not matter. The only thing that matters is that your hypotenuse is the term by itself, the C spot, okay? On the right side here, we have some Pythagorean triples. These are just common ratios of sides, common setups. So these guys are pretty much just good to memorize. If you don't, it's fine because you can always just calculate a missing side. But you'll see them come up a lot in your future math classes, and they just help speed up problem solving because you'll get to a point where doing the Pythagorean theorem is just one step of like a 10-step problem. So you'll want to be able to do it a little bit faster. Okay. So let's look at some examples here. So Will is standing 40 yards due north. Okay, so let's review our cardinal directions. So we have north at the top. Never eat soggy waffles, right? North, east, southwest. So Will is standing due north of point P. So let's draw point P. Here is Will. And he's 40 yards above it. Grace is standing 60 yards due west of point P. So here's Grace. Down here, what is the shortest distance between them? So the shortest distance will always be a direct route. That would be directly from Grace to Will. That's our unknown, okay? So we've created a right triangle here between north and west would be a right angle. So we can use our Pythagorean theorem to solve. A squared plus b squared equals c squared. Again, it doesn't really matter. For A and B, usually people put the smaller one first, the smaller leg. Doesn't matter at all. 40 squared plus 60 squared equals c squared. 40 squared is 1600. I'm using my calculator to find that. 60 squared, 3600, or knowing 4 squared and 6 squared equals c squared. Add them. Okay, so last step here, we have to get rid of this square. To undo a square, we can take the square root on both sides. And we're fine just estimating for these problems. So in the calculator, you can type square root of 5200, and that gives us about 72.11 yards. Yep. So always make sure you have a unit if you were given units to start with. Pretty straightforward. The second one I want to still do with you because there's a little bit more to it here. So for example 2, it says a 65-foot ladder is leaning against a wall. So our wall is going to be vertical. There's our wall. Its lower end is 25 feet away from the wall. So my ladder is leaning. I'm going to put it at the top here to make it make sense, right, with what we know. So here's my ladder. Leaning against the wall. The lower end down here is 25 feet away. Sorry, ignore that multiple choice. 25 feet away from the wall. How much further will it be if the upper end is moved down 8 feet? So there's a couple of things happening here. The ladder itself is 65 feet. So here's my ladder. I know the base down here is 25. I don't know how high the wall is. So what I need to do first before I even worry about the second part is figure out the height of the wall. So let's solve for that. This time we're looking for a leg. So I'm going to set up my theorem. 25 squared plus x squared equals 65 squared. Make sure your hypotenuse is the part that's by itself. We'll solve this guy. 65 squared is 4,225. Subtract 625, so x squared equals 3,600. I'm going to take the square root on both sides. So x equals 60. So that's the height of my wall. So I'm going to draw a new picture and say how much further away will the ladder be if the end is moved down 8 feet. So think about like if you had it leaning against a wall and you kind of pulled the bottom end of the ladder, it's going to come further away as it moves down. So let's draw another picture here. The ladder length hasn't changed. That still has to be 65. Now if I've moved down 8 feet, the height of the wall is now only 52. Right? Because instead of being at 60 feet high, the ladder is reaching 52 feet high. And this time, I want to know how much further away. So I don't know the bottom leg here. Again, I'm solving. I'm going to make this a y instead of an x. So set up my Pythagorean theorem. Plus y squared equals 65 squared. 52 squared is 2704. Plus y squared equals 4225. Y squared equals 1521. I know I'm going fast, but you can do those calculations pretty easily on your calculator. Take the square root. So y equals 39. So that's the new length. Now the question didn't ask for the new length, it asks how much further away will it be? So to actually answer the question, I was at 29, but then I ended up at, I was at 25, ended up at 39, so 39 minus 25, that's 8, means I was 14 feet further. Okay, so a little bit more complicated with the Pythagorean theorem, but as long as you can do the basic calculations, you should be okay. And the last one here, this is actually a multiple choice question. So I don't know, the first time I looked at it, I was very confused, but it's a multiple choice question, so these are our possible answers. Use the figure to find the length of BC. So we're looking for this length here. The little right angle symbol got a little skewed, so that's our right angle here. Okay, so we're going to kind of work our way to BC. I'm going to put an X on it so that I can use less variables. I have the triangle ABD, and that's a right triangle as well. So I'm going to find BD to start. And I can use my Pythagorean theorem to do that because these are my legs. And then I'm going to solve for the hypotenuse. So I have root 13 squared plus root 23 squared equals BD squared. So if you're using your calculator, notice I have the square root in parentheses. Just be careful there. But we also know that squaring a square root just undoes it. They're opposite operations. So root 13 squared is just 13. Root 23 squared is just 23 equals BD squared. That gives me 36 equals BD squared. I want to solve for BD, so take the square root. So segment BD, BD equals 6. So I'll put my 6 on the picture. So now that I have the hypotenuse of the other triangle, I'm going to solve for length BC. I'm going to use x here. So that's a leg. Right hypotenuse is always across in the right angle. X squared plus parentheses 4 root 2 squared equals 6 squared. Okay, so for the 4 root 2 squared, if you're using your calculator, use parentheses just like you see them on the page. If you don't want to use a calculator, you can do it really quickly by hand. 4 root 2 squared means you're multiplying 4 root 2 times itself. 4 times 4 is 16. Root 2 times root 2. That's kind of confusing. Root 2 times root 2 is just 2. 16 times 2 is 32. 6 squared, I want blue, 6 squared equals 36. X squared equals 4. Square root both sides. Therefore, x equals 2. Choice B. I'm done. Okay, so again, just be careful with the square roots. Use parentheses if you're in a calculator, or take your time if you're doing it by hand. So you guys have a Pythagorean theorem scavenger hunt that's on Class Kick, so you guys can do that when you're done watching this.